Okay, now we're going to look at two different financial models. The first one is an investment model. The second one is a pension fund model. Okay, here in this example, we have $100,000 to invest for the next 4 years. And there are 5 possible investment opportunities available. Each investment opportunity has a certain amount of cost involved that you have to cost outlay for different years. And then there is return coming back. And we have a limitation that for in any one given investment you cannot invest more than $75,000. And we want to look at 4 years of investment, and so at the end of 4 years or at the beginning of the 5th year, okay, we want to maximize our total cash position. And if you have any cash left over from going from 1 year to the next, and there is a 3% annual return on cash that is available. Okay, so let's look at the spreadsheet. So here are the inputs. So initial amount of cash available for investment, maximum investment in any one given opportunity, and the interest rate on cash going from 1 year to the next. And here we have the outlay, that is cost, how much investment you should put into each of these portfolios. Okay, so here for A, our outlay is $1 in year 1. So here it is $1 in year 2, this is year 1, here it is year 4, and so on. And here we are given the revenue coming back, the return. Okay, in year 2, for $1 invested in year 1, we get 50 cents back in year 2 and $1 back in year 3. So this again is input. Now we have to figure out how many dollars we want to invest in each of these 5 different opportunities available. And the maximum investment allowed is this. So let's give a name here. So that's the maximum allowed. Okay. So we have dollar invested. Let's give a name there. And we will not name this row because we are using the same label in 2 different places, and that will mix things up, so we will leave it as it is. Now let's look at the cash position. Okay, the beginning cash for year 1 is that. So that's the amount of cash that we have at the beginning of year 1. Now return from investment would be, okay, you have some product of the dollars we're going to invest with the cost here. So that will give us with the revenue coming back, returns on investment. So that will give us how much money we will get back. And cash invested is again some product of this with the cost. Now cash after investing will be, that's the beginning cash plus this is the cash that will be coming in, return on investment, minus the cash that is going out, and that will give us the cash left over for that year. So beginning next year, you'll have the cash left over in the previous year, now that will get us a return rate of that, interest rate on cash. So that would be the beginning cash position for the beginning of year 2. Now we can copy these. Remember, the dollars invested is already absolute referenced. The rest of them are relative anyway. So now we can copy these. Okay. You go up to year 4, and then for year 5 you go only these two. Okay. Then final cash position is the sum of these two. That's our objective function that needs to be maximized. Now let's give some names. So here, that's our objective function. So let's give the name there. Okay, dollars invested is already named. So now here we need to make sure that the cash after investing is not negative. It should be greater than or equal to 0. So we will give a name for that column. So we can set that up in the solver. Okay, so now let's go to solver, and we want to maximize the final cash position by changing is how many dollars we're going to invest in each of the investment portfolios. Less than or equal to maximum investment. I'm using this cell because that's the cell which has all 75,000, just one cell. We didn't name this row, so we'll use that one. And the cash after investing must be greater than or equal to 0. Okay. Now non-negative and simplex LP. We solve, and we have found an answer. So now let's do sensitivity analysis. Again, you solve a table. Let's look at one of them is run solver table, and what if we relax the limit instead of 75,000. Okay, so that's going to be our input, and we'll see 75,000 to 225,000. Okay, in increments of 25,000. And we want to look at as output how many dollars we're going to invest in each of these, okay, comma, control click the final cash. That's what we want to look at, and here is our results. So as the limit is increased up to 100,000, there is a change, and after that there is no change in the investment except for dollars invested in portfolio D. There is a difference. So let's look at portfolio D. It's that one. So that one is going straight up. Now we can do one more sensitivity analysis. Now let's suppose that we want to do a two-way solver table. Okay. And we want to look at the maximum per investment like before, and we also want to change the interest rate on cash. Now the output, instead of wanting to look at the dollars invested or the final cash position, let us suppose that we want to look at what is the maximum cash position that we have on hand. Okay. But that's not calculated in the model. So we need to calculate that and put that in a separate place. So let's use maximum cash after investing. Okay, so that's cash after investing, but we want the maximum, and we do that. Okay, let's format this to currency format, and we'll take away the decimal places. Now this is what we want as output. Okay, so whenever you have an output that is not explicitly calculated in the model, and you have to calculate it separately and then use it in your solver table. Okay, so let's run solver table, and we want two-way table. Okay, and along the first input is interest rate, and we want to go from, you have to type this in decimal values. So we want 0.005, that is 0.5%, which is 0.005 to 0.045, that is 4.5% in increments of 1%, which is 0.01. The second one is maximum allowed investment, and we want to go from 75 to 225 like before in increments of 25,000. Okay, and the output that we want is the maximum cash position. So click OK. So you have now the maximum cash position here for the two inputs.